So notes today, 3.4 is where we're starting at, and 3.4 deals with inequalities. Hey, class has started, guys. Let's start paying attention to what we got going here. In 3.4, it starts dealing with inequalities. Inequalities meaning, which symbol is that one? What's that one called? Greater than. And we also have that one, which is
less than.
And then if we add an equals into those, of course we have greater than or equal to. And if we take the less than and put a bar underneath it, of course that is less than or equal to. The thing about this section, though, is we're not limited anymore to just one single straight answer to our problems. Back in Chapter 2, we can only have one answer for x. I don't even think you guys are listening. Are you listening?
Yeah.
I wish I had a button I could turn computers off with. Okay. So, in Chapter 2, make sure in Chapter 2 we solved letters and we solved for x and we solved for those variables, but we only had one single answer. This time around, instead of having one single answer to our problems, we're going to have multiple answers. And so it gets into what's called set theory. And in set theory, that is the group of a group of elements that answer, in our case, the equation. And a set might be, and it's listed with the braces, so you got to be careful when you do these things in your Hawks that you use the braces for your set. So it might be the set of 2, 3, 4, and 9 might be the solutions that make your problem work out correctly. So you'd end up having all of those pieces in there that would end up playing a role for your answer of what your set happens to be. And you use these braces because within the braces, that means I can list what are elements, and that is the parts of a set. So I can list my elements in there and come up with what my values would happen to be for those and what takes place with those. Now the other thing that we have also in here is if you have a number line, at the tail end of each number line there is infinity. Yep. There's a negative infinity if I head in this direction on my number line, and a positive infinity if I head in the other direction. And so if I wanted to list, of course, all of my elements, in this case, all of my elements would be from a negative infinity to a positive infinity, because I would have all of the values that would possibly be in there for an answer to this thing. So if I'm listing all of them, then I would have those pieces that would become part of my answer. So you got infinities on the ends of whatever your values happen to be. There's also set theory, which is x with a line, and it says x is all real numbers. And how this is read is it's read x such that. That's what this bar means, is such that x is all real numbers. And if I have all real numbers, that means anything I can possibly put in there would be my answer. That doesn't look like it's very dark up there for you guys to read, is it? Let me know if this gets better. Is that getting better, or is that getting worse?
A little bit, maybe. That's better.
Is that better? We'll go all the way up to the top up here with it. That's better?
Yeah.
I think so. Okay. Because I'm looking over there and it's kind of not showing up real well. Oh, I guess I didn't close that. Okay, now it'll shrink. Okay. So that's a little bit better for you to read. And so you get those pieces in there, and you get what you happen to have with those values that you happen to come up with. You don't see that very often in Hawks. They do talk about it though in your values or in your areas that you happen to have within your instruction in this section. Then from there it talks about union. And union is all elements in each set. So if you have two sets, set A and set B, and I union them together, unioning means I'm going to have all of the values in there. Union means the word or. So you're going to see that sometimes within Hawks. It'll ask you whether it's an and or an or. If you have an intersect, that is the values shared between sets. So that's the stuff that we have between sets. So if I said set A was made up of the elements of 2, 3, 4, and set B is the elements of 2, 4, and 6, and I want to know where they intersect, the thing that they share is the 2 and the 4, so their intersection of A intersect B is going to equal the set of 2, 4, because that's the two pieces they share. That's the part that comes into play with those. If you looked at this on a number line, one line might start at 6 and the other one starts at 10. One line's going to head this way, the other line's heading this way. So their intersection is the stuff that they share. So that's an intersection where you have a sharing of two pieces of information. A union with a number line might be that one's at 10 and one's at 6, but they're going in opposite directions. And so you would have this set and this set, so you'd have shared stuff that you'd have going on in there. So you got some combinations of things. A lot of terminology with this part, because you got all these different pieces and different terms that you've got involved with it. And then they get into how do I put these things in place. And they have three different possibilities. One is algebraic. And an algebraic would be x is greater than 4. So if I wanted an algebraic notation, that's just having the letter involved and what it has for its comparison. The second method is interval notation. And in interval notation, there's some special specific stuff that we have happening with this. If you use a parenthesis, so parenthesis means the number is not included. Just like this has a greater or a less than or greater than in there, what that would mean, because there's no equals, and there's no equals, what that means is that I can't include 4. 4 is not going to be part of my answer, because I can't equal 4. It can equal anything but 4, but it cannot equal 4. If, and that would be when you have greater than or less than. If you have a thing that's included, you use a bracket, means the number is part of the answer. And you only use brackets, move it up again, you only use brackets when you have a greater than or equal to or a less than or equal to, because that means it's going to be included with your information. Okay? The other spot you always use parentheses is when infinity or negative infinity are involved. So you're going to use parentheses at that point for those with your interval notation. So if I wanted to take what I had up here and put it in interval notation, what would happen is I cannot include 4, but because it's greater than, it means I can include anything that is larger than 4, so it would go continually on to infinity. A parenthesis, because I cannot include 4, a parenthesis because infinity never ends. Does that make sense? It will once we get doing some problems with it, so you get so it ties in with what you have. The combinations that you can have with this, are parenthesis, parenthesis, meaning nothing is included. A bracket and a bracket means all values are included. A parenthesis bracket means these are usually used when you have a negative infinity to a number and the number is included, is when you use those. So part's included but the other part isn't. Or you can have bracket and a parenthesis. Each one of these end up showing up in your keypad that you have in Hawks. So you'll see all of those, so you can choose which one you want to use for your answer. So you're going to have each one of these pieces coming up in there that you can pick out, and you can show what's happening with your problem that you happen to have. And this is again when one thing is included. And the other isn't. And then what they also say is whether they're open or closed or half open. So if it's open, that means neither end is included. So items are not, values aren't included. If it's closed, that means it's a bracket and all values are included. And if it's half open, that's when you have a parenthesis and a bracket, or a bracket and a parenthesis. And again, it's going to make more sense when we get some numbers that we can put in here and know what it's asking you to do. Okay?
So by the parentheses and brackets, will let us know what we...
Yeah, it will tell the person who's looking at your answer what you're telling that person's included in your problem. Yep. So each one of these things is kind of a key to the stuff that we're going to do. So we have the algebraic, which has the variable involved with it. Another one that would fit in an algebraic might be 4 less than x less than 2. We've got some double combinations of stuff that fit into the algebraic method too. So what this means is x is somewhere between 2 and 4. Okay? And we'll do more with that when we get to our problems and what makes our solutions correct. Interval notation, again, everything we possibly can use. Now these parentheses also close at the other end. The brackets can also close at the other end. So you got them going both directions in here to make your patterns and make your combined values that you have. Okay? So far so good? Now the one that gives you a picture is the next one, and that one happens to be graphing. So that's method 3. And in Hawks it can ask you to do any one of these or all 3 of them. So it depends on what part you're asked to do. Some of your questions in there might be 4-part questions or 5-part questions. And the same thing happens with your test next week. You get some that have lots of questions or lots of pieces to them that you're working with. So if I'm graphing and I have x is greater than 4, what does that look like on my graph? Well, you're graphing a number line, and your number lines don't have to be elaborate. So don't say, oh, I got to put all these numbers in there. If you simply put the number that you're given, which is 4, put a number on either side of it, you will have an idea of what's taking place with that. Now realize at the right-hand end of this, you go to a positive infinity. On the left-hand end, you go to negative infinity. Okay? Now in Hawks, they will have all the numbers printed in there for you because they will have a full number line in there for you to maneuver in. And when you maneuver it and you lock on and say you're given a number line to change, there's going to be a little arrow at the bottom. If you click your cursor on the arrow, it will let you move your thing up and down your number line. Okay? So it will let you move that and let you shift it into wherever you want it. So what does this tell me? So it tells me if my variable is on the left, so if the variable is on the left, the inequality tells the direction on the number line? Because it's telling me I want to go greater than 4, you're going to locate 4. This point tells me my line is going to head in that direction, but it doesn't end because there's no stopping after 4. It just keeps getting larger and larger and larger. You okay so far? Because there's no equals, you will put a parenthesis above your 4, and you will also have a parenthesis at the tail end of this, but it won't show because it'll go off into infinity when you do that. Now, in Hawks, it will say choose your pattern. It will give you parentheses, it will give you brackets, it will give you a bracket and a parenthesis, and it will give you a parenthesis and a bracket, and you need to choose which one you have. Now, because this is open at the tail end because it never ends, and it's open at the beginning because it's not at 4, I would click on parentheses and it will put those on your number line for you.
Okay.
And then you'll see your distance.
Okay, so it would start at 4 even though it says greater than 4? Or would it
Yep.
start at 5?
Nope. Because between 4 and 5 there's a whole bunch of numbers in here that I can use that would still make it true. They're all decimals, but they still make my equation true. So this whole piece I'd have to use, but the parenthesis above 4 tells me I cannot use 4.
Okay.
Okay?
Okay.
Yep. Now, if it would have had x is less than or equal to 4, what does this one tell me? So again, my number line with a 4 and a 5 and a 3. My arrow from my inequality, because my x is on my left, is telling me to go to the left. Where is it leading me to? Where is it taking me to at the tail end of my number line? Taking me to a negative infinity. Okay. Equals is in here, so what should go above the 4? Well, because it's included, I need a bracket above the 4. So which one of these would I pick? Well, if I need a bracket above the 4, going out to a parenthesis, because I don't know where it ends, I would have to choose this one when I picked my value for that. So what has to go in there? Then it's real easy, once you get the algebraic, the graphing, to head back and do the interval. Because if you just look at your problem here, it tells you we're going from a negative infinity to 4. Can't include infinity, but because there's an equals, I can include 4. Okay? So I can include 4 in there. So I don't have to have that where I can't include my value in there. So I can include 4 because it does end up being part of my problem and part of my answer of what I have. The others that they give you might be something like 2 is less than or equal to x, and x at the same time is less than or equal to 6. Doubles in here. Because x is in the center, what is it telling me? Well, if you take a look at these, and we end up with these in our problems today, if you look at it and we break it apart, x is in the middle. So x has an opening towards x, and it has a point towards x. So if I look at just this piece, and I ask myself, well, what does that mean? What does x have to be? Is x less than 2? Or does x need to be greater than 2? Which way does it go? Greater. So I would, if I had this problem, I would take this piece and reverse it, because x, remember the alligator? We talked about the alligator a long time ago. The alligator wants to eat the largest amount. So leave the alligator's mouth open towards x and put a 2. Then the second piece of this says I have x is less than or equal to 6, and it looks just like it should look. So what I did is, again, I looked at x in the middle, rewrote it, because this will tell me what way to go on my number line if I look at it. So x needs to be greater than 2. So what's my number line going to look like? So here's 2.
So you just split it in 2 basically.
And here's 6. Okay? So what is my, it's telling me this goes to a negative infinity and this goes to positive infinity. So what is it telling me? The first one says I'm going to leave 2 and head this direction, right? Because I want things bigger than 2. 2's included, so it's a bracket.
Okay, so you use the bracket one, yeah.
Yep. Where does 6 tell me I'm going? 6 says I'm starting here, but I'm going to go this way, right? And what goes above 6?
A bracket.
A bracket. So what really makes this solution true? Because it has to equal both things. So what makes it true?
Anything
Between the 2 and the 6?
Yeah.
So in between these two, so if I went to interval notation, what would I have? Well, my answer would be a bracket, 2 to 6 with a bracket. And this tells the person looking at your problem, I want only pick numbers between 2 and 6, including 2 and including 6. So I could put a 5 in here and it would work, right?
Yep.
Because 2 is less than 5, and it's also 5 is also less than 6, so it meets my specification. So you got some things that overlap. Okay? Yes or no?
Could
Okay.
be another?
Yep. So now, if you have the combination of x is, well, let's do it this way. X is greater than 2, but less than a negative 1. What happens with this one? Or x is greater than a negative 1 and x is less than 2. What's that one going to look like? So if I reverse it, I'm going to have x. The point is going to go towards the x still with a 2. And this one's going to be x is greater than or equal to a negative 1. So what does it look like on a number line? And I think number lines are real helpful to you because they start showing you what you happen to have and what directions you go in. So if you always do a number line, you won't get lost, hopefully. So it says things that are, x needs to be less than 2. So what does that mean?
2's included.
So,
So I'm going to go this way, right?
Yeah.
What's above the 2?
A bracket.
A bracket. If I go this way, what's above the 1?
So it's going the other way.
Mm-hmm.
And interval notation would be -1 and 2.
Mm-hmm.
bracket.
With brackets. Mm-hmm.
Correct.
Yep, with brackets.
Alright, I got it.
Okay, what's comments? Anybody else have stuff on this one? Are we okay? Are we not okay? Okay, because this part is what you got to get, because if you get this piece down, then you got stuff that's happening in the right way. Here's one more. 0 is less than x, but x is greater than or equal to 5. What's going to happen with that one?
So 0
So rewrite it. X is
greater than
0 and x is less than or equal to 5. So what does it look like on a number line?
so 0. So we'll have 0 to the,
So what way do I go?
so it'll be a parenthesis.
A parenthesis above 0?
Yes,
What way is it going?
to the right.
What's above the 5?
A bracket.
And it's going.
The other way, less than 5.
So what's my answer?
So
An interval?
parentheses 0
Mm-hmm.
and 5 bracket.
Perfect. Yep. Okay. Yes or no?
Don't ask me how I'm getting it, but wow.
Okay. That's the main thing. Main thing is that you are getting what's coming out of
I'll
those.
what you got on here, but when I went to this practice, just to kind of look at what.
Yep, and we'll have to take a look at that. So if 0 is let's do it this way. X is greater than 0, but at the same time x is less than a negative 4. What's this one going to look like?
Ooh. Alright, so 0 that way, -4, x is less than. Alright, so you'll have parentheses 0.
Which way? To the right?
To the right.
Okay.
Then we'll start at -4 parentheses.
Going
And
where?
then we're going the opposite way.
To the left. Mm-hmm. So, what would I have for interval notation?
None. You don't have any.
Yeah, you do, because you, in here, you have a union of these two sets. So you have two pieces of interval notation. So negative infinity to a -4, parentheses on both, because I can't include it, and infinity I never know where it ends, so it's a parenthesis always. Union with the opposite one, which is 0 to infinity.
Oh, wow.
So you can have double cases of intervals. But again, always make sure that you write your stuff out so that you get your x's and your variables, and get your x's on the left, variables or numbers on the right, and so then you'll be better off at what you got going. Okay? Ready to try a few?
I don't know.
Okay, let's try a few. See what happens. What they end up looking like, and that's again, you've got your answers in there of what you happen to have. Oh, let me find a, how about this one? They come out looking like this. 5x plus 4 is less than or equal to a -1. So that's what my problems are going to look like in here. So the first thing that you're going to do is, in most cases, sometimes they put parentheses in there. So you're going to first remove all grouping symbols. So get rid of all grouping symbols. Do I have any grouping symbols?
Nope.
Nope. Step 2, get all letters on one side. And when you do that, remember in chapter 2 I told you to move the smaller of your letters? So move the smaller letter. What that's going to do is keep them positive all the time, so always move the smaller one. Do I have to move any letters in this one?
Nope.
Nope. Step 3, get all numbers on the opposite side of the letter. So, do I have any numbers I got to move? Yeah, I got that 4 here, so I'm going to -4. So basically you're doing it just like you had an equals in there. Don't let that inequality flub you
Yeah,
up.
that's what I was.
So I get 5x is less than or equal to -5. Then get x alone, or get the variable alone.
I have a question.
Yep.
When you divide by negative, you switch to something?
Yes.
But if you don't
Yeah.
divide by negative,
Just leave it the same.
okay, so you only switch it if you divide by negative.
Yes.
Okay.
Yeah. And the question was, and I don't know whether that'll get recorded on here or not, but if your variable had a negative in front of it, and you divide by, let's say this was a -5, I have to flip my inequality in there. Okay? So get the variable alone. If negative, switch the inequality. If you don't switch that inequality, you're going to get the wrong answer. Okay? So in this case, I'm going to divide by 5. So basically, it's the same stuff we did in chapter 2, but it's just now we have inequality stuff involved in it. And so I get my answer. Now what this looks like is what we've had before. So if your Hawks ask you for algebra, the algebra statement, your algebra statement is going to be just the same as you get for an answer. So your algebra is going to be just what you have. If it asks for graphing, then that's where I need my number line, like we just got done doing, and figuring out what way we're going to go. What way are we going to go? To the right? Yep. Nope, to the left. Yeah. To the left. And what do I put?
Bracket over the -1, parentheses over...
Yep. Parenthesis over here. Out to infinity. Correct? We got that all right?
An interval notation.
Bracket because of
Equals.
the equals. Yep. Heading out in that direction. And interval?
Interval notation would be -infinity
to
negative
-1.
one. Was a parentheses by the infinity or bracket by -1?
Yep. Yep. And then step 5 is write the answer as requested. Okay? So that's our steps that we gotta go through to solve these. Not any different than chapter 2. Everybody see that? That's not any different. It's still doing the same stuff, moving your 4 over, dividing by your 5. It's the same exact stuff. It's just that when you get all done, you got some extra things you got to do with it to come up with your answer. How about this one? X plus 1 is greater than 3 minus 2x.
So it's get all numbers on one side, all variables on one side.
So who do I want to move?
Let's move the x.
Negative 2x, right? 'Cause that's the smaller of my x's. So I'm going to add 2x. Okay?
So we have 3x.
So I get 3x plus 1 is greater than 3. Now what? Minus 1. So now what do I have? Well, I get 3x on this side greater than 2. Divide by 3. And I find out that x is greater than 2/3. Okay, is 2/3 create a problem? Shouldn't, because in Hawks on your number line it'll let you move your value over to 2/3. So if they said enter algebraic, that's what I have. Okay, that's when you get your letter in there, is the algebraic one. If it said graph, number line, so here's 0, here's 2/3, and there's 1. So what way do I go? To the right. And what do I put above it?
There's no bracket, right?
Nope, no bracket, because there's
No equals.
no equals.
Alright.
Okay? And it's heading to infinity. Okay? Interval? What happens with interval?
Parentheses,
Mm-hmm.
2/3,
Mm-hmm.
and then infinity,
Yep.
and that would be
Parentheses as well.
Parentheses.
Wait,
Yep.
is that a parenthesis at the end of the graph?
No, this is it's an arrow, but it is a parenthesis because it's heading to infinity. In Hawks, when you're in Hawks, you will have two pieces. It'll come up with a parenthesis here and a parenthesis there. You got to lock on this one and move it down to 2/3. And then you got to lock on this and move it over to infinity.
Hawks is gonna make you pick your brackets and your
Yes,
parentheses
first, before you graph
so
it.
what I would recommend is solving the whole entire problem before you start actually.
Yep, yep. Because, but if you put this piece together, then it helps you get your interval done. Okay? So you're going to need these to figure out what piece you've got going. Okay? Yep. What?
if it's equal to, you're gonna use that. If it
Okay.
doesn't, you're gonna use that.
This is like, I get it this time around, this is so simple.
I remember this stuff.
Good.
I can't.
Okay. All right. We okay with this? So far on that one? Okay. All right. Let me see if I can find. I keep running into these doubles in here. I don't want to double just yet. Oh. How about this one?
Triple one with,
We will do one of those in a second. Z plus 1.1 is less than or equal to 32.7 minus 3z. How about this one? Which letter do I move?
Alright, well, negative
Mhm.
3z,
So I'm going to add 3z to both sides.
so 4z.
Okay. So it gives me 4z plus 1.1 is less than or equal to 32.7. So far so good? Mm-hmm. And 32.7 minus 1.1 is,
31.6.
okay, divide by 4. So what's it going to equal? 31.6 divided by 4?
7.9.
Okay.
Which in fraction form,
Okay. 7.9, I think it accepts either one. It started out as decimal, so they should accept a decimal for your answer. Okay, so
that would be 79.
graphing it. This is again algebraic, so what's my graph going to look like?
Going to 11.9.
So here's 7, 7.9, and 8. So which way do I go?
Left.
To the left? Yep. What do I have? A bracket and a parenthesis. So then if I do that piece, then my interval I will know. Parenthesis, negative infinity to 7.9 with a bracket. We okay? Yes?
So you do have to follow it down though, like with the bracket and the parentheses.
Yes.
You follow it, you know what
Yep.
I'm saying?
Yep. Yeah. So if you get this solved, go to your graph next so you can see which way it's going. Then go to your interval and then look at box and say which one are they asking me for. Okay? Because some will only ask you for intervals, other ones will only ask you for graphs, and others will only ask you for the algebraic one. So just be careful with that you've got all of your pieces in there. Okay? Good?
How about a free term?
Yep, that's where we're heading. Are we okay on two-sided ones?
Yes.
Okay. If we go to a 3-1, let's do this one. Negative 8 is less than z minus 3 is less than 4. Now it's a triple because it's got this in the middle and this at the tail ends. Okay? You can look at this problem as if it's a two-parter because you could solve it that way. Solve this piece first, then go back and solve that piece. Okay? Or we could do it all together. And if we do it all together, what that means is this is where I need to solve my pieces at. So my goal is to get z by itself in the center. So how do I do that? Well, I treat this as if it were just a single piece. So what would I have to do? Well, I'd have to add 3 and add 3. But because it's a triple, I add 3 here, I add 3 there, and I also add 3 there.
So what you do in the center, you do to both sides.
Yep, whatever you do to the center, you do to the outsides. Yep.
Wow.
So negative 8 and a positive 3 is a negative 5. Z is the only thing left in the middle because negative 3 and a positive 3 disappear. And then what am I left on the other side?
11.
I'm left with 7.
Okay, let's add a coefficient into the variable.
Wait.
Just wait, we can't jump into too many things here. Just a minute.
Time disappear, Marcel.
No, I think she tried to put it in. Add the other greater than.
What sign disappeared? Oh, yeah, I didn't get my sign in there.
Oh, alright, I was just
Thank you
saying,
for
well,
asking. No, that was me. That was me, I didn't get my sign in there. And so, what do we have now? This is that triple stuff we were talking about earlier. So really, I have z is opening towards z greater than a negative 5.
And then we have
And z is less than 7. Okay? That's what you have to put in for your algebra pieces in here. Okay? Because your algebra pieces, if you're asked for that, you can't put this piece. Well, I guess you could put that in there, but sometimes it's going to ask you to break it apart. So if we break it apart, those are our two pieces. What does it look like as a graph?
you're gonna have nothing but parentheses.
Negative 5 and a 7,
So we know that it's open.
and a negative
parentheses.
infinity and a positive infinity out here.
So open parentheses at negative 5 going to the right.
Going to the right? And is it open or closed?
Open.
Open.
Both
Mhm.
are open.
Both are open. So that's this piece, and then what's the other piece?
It's going to the left, open parentheses on both.
Okay, now if they overlap, remember we only have the piece that overlaps for our interval.
Negative 5, parentheses negative 5,
7.
and 7. Parentheses.
Yep. And that would be your interval notation. Okay? Yes or no?
Yes.
So far so good? Okay. Now, let's do another one that's got doubles in there of stuff.
Hard. These are a little hard.
Let's try this one. I think it can fit right here. 3 is less than 2x minus 1 is less than 1.
So we're going to add 1 to both sides.
to all sides. Okay, so if we add 1 to all sides, we're doing good?
Yes.
We got all okay with that part?
Yes, so
Okay.
it's gonna be 4,
Less than
2,
x less than
2.
2.
Now
Okay,
divide both sides by 2.
right.
Okay, simple.
4 divided by 2 is 2.
Less
2
than-
divided by 2 is x.
and that's it.
And 2 divided by 2 is 1. Okay? So what does this tell me I have in my answers?
X is greater than 2.
And
X is less than 1.
Okay.
Now
Okay
we
with that
graph
part?
it.
Now what is the graph going to look like? Here's 1. There's 2. What
Okay.
way do we go?
Open parentheses 2
Heading which way?
to the right.
What's above the 1?
Open parentheses
Heading
to the
where?
left.
Okay. So now what happens if I write this in interval notation?
you get negative infinity
Uh-huh.
to 1.
Yep. With
Parentheses.
And then the u, right?
Yep.
And then open parentheses 2 to infinity.
Perfect. Close it with a parenthesis. There you go. All right.
There's a united if they're not overlapping.
Yes. They're intersecting if they cross each other. Okay? Yep.
Okay.
All right. You got one?
Yeah,
All right. What you got?
so a negative 12
Yep. Negative 12.
is less than or equal to a negative 3/2 z minus 3
Yeah.
is less than or equal to 3.
Okay. That does look like a good one. Okay. What do we got to do first?
Flip the fraction.
Add 3.
What do you have 3 to?
Everybody gets a 3.
Multiply that by 2.
Yes, you could do that too. Yep, and get rid of your
Did
fractions.
you wait until you or
Yeah, I would on this one because I don't have many fractions. If I had a fraction here and a fraction there, then I would have found the common denominators and did what you're talking about there, Amy.
It's
I'm
just
multiplying
like
everything through by 2.
solving for an algebraic.
But in this case, I only have one fraction, so there's not a real big need to do that. So negative 12 plus 3, what do I have left? A negative 9, right?
Yeah.
Negative 3/2 z is less than or equal to 30 plus 3 is 33. Okay. Now I would clear out my 2. So how do I get rid of my 2? Multiply everybody in here by 2. 2 times a negative 9 is a negative 18. Negative 3z and 2 times 33? 66. We okay so far?
Yep.
Okay, now, what I have inside of here is this negative thing. So what did we get done saying? Every time I divide by a negative, I need to do what?
Flip the
Reverse
thingy.
the
Flip
sign.
my sign. So I'm going to divide by a negative 3 here, divide by a negative 3 here, and divide by a negative 3 there.
So both sides
18,
flip.
yes, both signs are going to flip. Negative 18 divided by negative 3
4.
is 6.
Oh.
But it's a less than or equal to, but I'm going to switch it to a
Greater.
greater than or equal to
Z.
z, because these guys cancel.
Greater.
Flip my sign again, because I got another 66 divided by negative 3.
Negative 22.
Yep.
Whoa, how'd you get 66?
2 times 33. Remember, we multiplied everybody by
Less
2.
than 30. Okay, I just
So 30, this is a 30.
Okay.
Yep, that's how. Okay, what's this thing going to look like?
Alright, so.
So if I graph it,
Greater than, right?
here's the negative 22,
It's greater than 22.
and I have a 6, so I've got that on the other end. So what's taking place?
Bracket negative 22. Going to the right. Right?
So bracket, heading to the
Right.
right? Now be careful, we got to make sure we reverse this. So this is z is less than 6 or equal to it, and z is greater than or equal to negative 22. So we're fine. No, you're fine, because you're heading in the right direction. Yep.
I would have messed up on the other one.
Yep. Make sure you flip them, switch them around, because if you don't, you'll go in the wrong direction.
Yeah, I could have
Okay?
just made it.
Be real careful with that. Okay. So that goes that way. What does the other one do?
Less than, z is less than, so you want an open bracket.
Do I want open or closed?
Close.
Close, I mean,
Close.
A bracket.
Yep, because it's going to go that way from 6. So what's my interval?
So you know it's negative, bracket, negative 22,
2.
and 6.
Yes, with a bracket.
Bracket.
Perfect.
Infinity.
Yeah, because they're,
Do I need infinities? No, because they overlap each other. Their answer is overlapping in the middle. Okay? So because it's overlapping in the middle, I don't need the infinities in there at all. Okay or not okay? Yes?
This one I was correct, like, you flipped it because of the sign or because of the fraction?
Nope. I flipped it because this was a negative 3.
Okay.
If this would have been a positive 3, I would have never flipped anything. Okay? But because it's a negative 3, anytime I have a negative in my inequalities, I need to flip them. Okay? Yep. Okay.
Another one like that with the three?
Yep. See if I can find one. This one doesn't have a fraction in it, but it still does the exact same kind of thing. So negative 1 is less than a negative 2z minus 3 is less than 3. So, what do you guys want to do? We're going to add 3 to everybody. So negative 1 and a positive 3 is 2. Negative 2z is in the middle. Less than, because the 3's are gone, 3 plus 3 is 6. Okay. Now what would you want to do? Mm-hmm. 2 divided by negative 2? Negative 1. Flip my sign, because I divided by that negative piece in there. Negative 2 and negative 2 leaves me with z. Flip my other sign, and 6 divided by negative 2? Negative 3. Okay? Yes? No? What do you think? What's it look like as a graph? This is algebraic, okay? What's my graph going to be? We got negative 1, and we got negative 3. Reverse it before I do the other part. So it's going to be z is less than a negative 1, but z is going to be greater than a negative 3. Negative 1 to the left. What do we have, brackets or parentheses? Parentheses, okay. Negative 3, also a parentheses, so what's my interval?
Parentheses, negative 3, negative 1.
Right. Now, if Hawks ask you whether this is an and or an or, this is going to be an and. This goes in between those because it's an overlapping, okay? If it's an or, it will be where they're heading in 2 different directions, okay? So one would go this way and one would go that way if it were an or. What was that?
Isn't that what that's doing? One's going one way, one's going the other way.
But they're overlapping. The answer is an overlap in the middle. Yeah, it's where the 2 cross each other at.
Like if you had a 4 and a negative 3 and your 4 was going this way and your negative 3 was going this way, then it would be an or because they were going opposite ways.
Right. An or would be, if we go back to that example, you had a negative 3 and a 4. If 4 goes this way and 3 goes this way, then you have an or, because I got to include this one or this one for both of my answers. So my intervals on this one would be parenthesis negative infinity to negative 3, or you'd put a union in there, whichever you happen to do, 4 to infinity. Okay? Yep. Okay, you think you got it?
Okay.
Or we need another one?
Yes, one of the hard ones with the, fraction in it.
With the fractions in it? Okay, let me keep digging here in my pile of stuff I have for examples. How about this one? Negative 8 is less than or equal to 2. 3 halves z minus 1 is less than, or 2 I should put in here, is equal to 1. Let's work that one out. See what you get? What would I have to do first? Add 2. 8 plus 2, negative 8 plus 2 is 6. Negative. 3 halves z is the only thing left in the middle. They must like z's for some reason. 1 plus 2 is 3. Okay. Now what?
Times by 2.
Yes. Everybody. Don't forget somebody in here or it will make your answer wrong. 2 times negative 6. 2 times this leaves me with 3z because the 2's cancel. And finally, 3 times 2 is 6. Okay, now what?
Divide everything by 3.
Yep. Everybody gets a 3. Negative 4 is less than or equal to. These guys cancel. Less than or equal to 2. So, graphing it.
Wait, that's your answer right there, right?
This is an algebraic.
Alright.
If I graph it, negative 4 to... What way am I going? So, rewrite it though. It's going to be z opening towards z negative 4, because you'll go the wrong way. Always rewrite these. Z is less than or equal to 2. So what way do I go?
1 greater than 1 less than, in brackets.
Yep. Okay. And what way does it go for the 2?
Less than.
With a bracket. So my answer is the overlap. So an interval. And that's your answer.
Wait, and here we go again. Parentheses. Are the parentheses at the end?
Oh, at the end? Yes. Out here they would be. Yeah. Because these are going off into infinity on both ends. Negative infinity this way and a positive infinity that way. Yeah. So in Hawks, when you're picking these, you would, for this piece here, z is greater than or equal to a negative 4. You're going to pick bracket parenthesis on your number line. The second one, z less than 2, you're going to pick on this one a parenthesis and a bracket because it's included and it's heading this way.
So why don't you have infinity again in that?
Because they overlap in the middle, so I don't need infinity for my final answer.
So, you're always going to have to put parentheses at the end then?
For infinities, always. Infinities are always parentheses. Yep. They'll never be brackets because I don't know where they end.
But this is an infinity.
No, this is your interval answer. But in Hawks, it's going to ask you to put the stuff on your number line. They'll give you 2 different colored number lines. You need to pick what you've got, whether you've got a bracket and a parenthesis or a parenthesis and a bracket for your number line. You'll see it when you get into Hawks. You'll see it when you get into Hawks.
Parentheses at the end of the line, but it's not an infinity for algebra.
Right.
Because this one, if you're at a negative 4, it's telling me I go this way to a positive infinity. If I had to just do the interval, just this piece, the interval only of that, then that interval would be bracket negative 4 to infinity with a parenthesis. If it were only that piece.
Right, but we're not doing only that piece.
It may ask you for only that piece. Because it may ask you only to graph this piece in Hawks. When you get into Hawks, you'll see what it does with that combination. Okay or not okay? Okay, I think it's time for a break. Stop this. 3.5, it has 2 parts to it. We're only going to do one piece today. So we're going to do 3.5a, and it's dealing with absolute values. And absolute values, if you remember way back when, we had that back in chapter 1. And the absolute value of 8, what's the absolute value of 8? 8. If I had the absolute value of a negative 8, what's its answer? Is 8. We okay with that? Because whatever's inside of here, when I take it outside, becomes positive. We all remember that. Well, the problem comes in when you have the absolute of x is equal to 8. What would my answer be? Well, if I have the absolute value could be 8, what could x possibly be in here? Well, x could be an 8, or x could be a negative 8. Okay? So it's like we have two possible answers that we could plug in for x. And so if I were going to write my solution out, I would write this as a set notation because it could be 8, or a negative 8 would be my solution to that. So you're going to get into some set notation type stuff in these. There's no inequalities in the absolute value stuff yet. That's next week, but not today. So if you had the absolute value of y equals 4, what could my possible answers be? 4 and, whoops, a negative 4 could be my solution to that. We okay with that part? Okay. Now, what if I had the absolute value of y is equal to a negative 4? What happens then? Do I have any values of y that are going to give me a negative 4? No, because what I know with this one is whatever I put in here is always going to come out to be positive, so it can equal a negative 4, so this one has a no solution. I can't come up with anything that's going to give me a negative 4 when I pull it out of the absolute, because every time I do an absolute, absolutes are always positive when I get done with them, okay? Never can be negative, so I might want to make sure I remember that my absolutes can never equal a negative value. Now, the thing that happens with these is inside of the absolute, they might give you x plus 4 is equal to 8. So what would I put in here for x now to come up with an 8 every time when I get all done with it? 4. So 4 would be one of my answers, but could I put something else in there? But a negative 4 plus 4 is 0, so that doesn't equal 8, does it? Okay? So what I have to do with this, the positive pieces are easy to find, but the negative aspects of it sometimes aren't as easy. So what happens with this is we come up with two possible solutions. One possible solution is if x plus 4 equals 8, or the other one is x plus 4 equals negative 8, because we said that if this equals 8 or a negative 8 inside of that, we're okay, aren't we? So what's my other answer? This one, if I minus 4 from both sides, I get x equals 4. We found that one, but how do I find this one? Same thing, so I minus 4. So x could also equal a negative 12. Yep.
So I got a question, Marcel. When you enter something in the Haas and you got the right answer and it's saying you don't have the right answer, what's the problem there?
Sometimes in this section, in these two sections, and then in 3.4 and 3.5a, it's usually because you didn't use the right parenthesis or the right bracket or the right something.
Exactly what you're supposed to do for the solution.
Okay.
It's exactly what it's supposed to do.
I'd have to come and look at it, Amy.
All right.
I don't know. This thing back off of here, thing back off of here. Okay. So when you do these, you get two answers, and you put it as a set notation of 4, negative 12. Or, again, it may get picky in there and want these in order too, smallest to largest. And so that would be your two answers that you'd have for that one. Okay? And then they just keep upping what gets inside of your absolute value. So how about this one? 3x minus 5 absolute is equal to 2. What happens to that one? So what two possible solutions could I have? So we know this could come out to be a positive 2.
Or it could come out to be a negative.
Or it could come out to be a negative 2. Right. And then you solve them. So I'm going to add 5. 2 plus 5 is 7. Divide by 3. So x could be 7/3. Or, if I solve the other one, negative 2 and a positive 5 is a positive 3. Divide by 3. And I find x is equal to 1. So my answers to this are 7, 3, and 1. Again, use braces because you're looking at set notation with
Now,
those.
does it matter what order you put them in?
I think it's going to get picky on you. Now I got these out of order because 7/3 is bigger than 1.
Yeah.
I don't think it.
You go from smallest
I
to
don't think it.
biggest, right?
Yeah, from the smallest to the largest. Yeah. Yep. But I think it takes both. I don't think it's that picky. I think it lets you put in both
If I keep getting it
pieces.
wrong, I'll know why.
Yeah. But I don't think it gets quite that picky. What about this one? Absolute of 4x minus 5 is equal to a negative 6.
There's only one solution.
So it's not 1. It's going to have no solutions.
No solution, how's that?
Because it can never be negative.
Can't equal a negative.
Oh.
Any absolute always equals a positive, so it can't equal a negative. And so you got to watch your pieces that
It confuses
come
me
out of
though,
those.
because why do you solve for the negative if it can never equal a negative?
Why could this never equal a negative?
Well, why do you solve for a negative for that? If it can never equal a negative. See, you have 2 and then you solve for negative 2.
Right. Oh, up here?
Yeah.
Because what you're saying is this 2, if this 2 came from the inside of this, inside the absolutes, this 2 could have been inside the absolute, it could have been a positive 2
Or a negative.
or a negative 2. Because if I plug it back in to either, if I put these answers back in here, let me show you it that way. If I take the absolute of 3x times 7/3 minus 5 equals 2, 3's cancel, so I have 7 minus 5. 7 minus 5 is the absolute of 2, which is 2. Okay? Then if I put 1 back in, 3 times 1 minus 5 in the absolutes. 3 times 1 is 3 minus 5 gives me a negative 2 inside the absolutes, which when I take the absolute of a negative 2, I get a positive 2. That's why.
So the X
You can
is
get
coming
2
from the
separate answers.
absolute, it's not coming from
Exactly.
the-
Yep.
Okay, I got it.
Yep. The X is inside the absolutes and what you're solving for within those. Okay. If your absolute is not all by itself, such as if you have the absolute of 4y plus 5 minus 4 equals 0, I need to first get the absolute by itself. And that is what's called standard form. So is my absolute all by itself?
Nope.
Nope. So I need to add 4. So it's kind of like doing a problem within a problem. Now I will find that my absolute is all by itself on this side, and so then I can solve it from there. The 2 equations are going to be 4y plus 5 equals 4, or 4y plus 5 equals a negative 4. And then you would solve it and get your 2 answers from there. So minus 5 gives me 4y equals a negative 1. Divide by 4. Y is a negative 1/4. Or over here, negative 4 and a negative 5 is a negative 9. Divide by 4. Those 2 are my answers for it.
What if you got something like 4y plus 5 equals 2x plus 3?
We're going to go there in a second.
Alright.
We're not there yet. Okay, not there yet, because I don't want to get too far into. I want to get these down so you know what you're doing with those, and then we'll work on the other one. If it's got a number out in front of it, such as 3 absolute x minus 5 absolute minus 9 equals 0. I got doubles I got to do here. I need to move my 9 over. But absolute's not by itself yet, because this 3 is multiplying it, so then I gotta divide by 3. 9 divided by 3 is 3. Now I can break this to my two parts. X minus 5 equals 3, or X minus 5 equals a negative 3. So you got two pieces happening there. So X could be, if I add 5, 8, and if I add 5, X could also be 2. So that's my two pieces. So in my answer it's 2 comma 8 would be my answer. Okay or not okay? Yes? You think you can do those?
Yeah.
Yeah?
Do
Hopefully.
one more just for the heck of it.
One more? Okay.
Do you have like fractions or anything?
Yep, we'll do those in a minute. So if this were my problem, I would add 16. When you do these, this piece is absolutes acting like it's a variable to get all your pieces on the other side. Then you divide, of course, by 4. And then you would solve it from there. And I think we're okay in solving it from there. Do I need to finish that one? Are you okay? Because again, it goes two routes. Y minus 4 equals 4, and y minus 4 equals a negative 4. I guess I can finish it. Add 4. So y could be 8, or y could be 0. So either one of those would give you the correct solution to that. Okay? Plug them back in. You can find out 8 minus 4 is 4. Absolute of 4 is 4. 4 times 4 is 16. 16 minus 16 is 0. 0 in here is a negative 4. Take it out. It's positive 4. 16 minus 16 is, of course, your 0 that you have in there. The other ones in here that they give you are where you got two absolutes on each side. If you got absolutes on both sides, then what you need to do is, again, set it up the same way. Drop your absolute, so it's going to go the route of 3y minus 2 is equal to the negative 2y plus 4. Or it's going to leave the first alone and take the negative of the second piece. Because remember before we took these two and left them as they were with the positive here, and then we changed it and put a negative on the other end? Same thing happens with that.
What if you don't have
But,
a negative?
pardon?
What if you don't have a negative?
You always will. Because regardless of what you have coming out of here, you're always going to have it equal some negative value, because when you take the absolute of a negative, you get a positive. So you always go the opposite route. Okay? So, opposite on the second side. So you need a positive piece and a negative piece. So you need both parts to that. So if I finish it, what do I move? So it's like two problems here. So what do I move to get my answer? Do I move the 3y or do I move the negative 2y? Always, again, practice that moving the smaller one, because that's always the more beneficial. You keep everything positive that way. Then move the 2 over. 2 plus 4 is 6. Divide by 5. Y is equal to 6/5. Then do the same over here, but before you move anything, you need to multiply. Negative 1 times 2y is a positive 2y. Negative 1 times a positive 4 is a negative 4. Again, all those rules from chapter 2. Chapter 2 is kind of the base for everything. So, move my 2y over. Add 3. Negative 4 and a positive 3 is a negative 1. So there's my two answers. Okay? What was that?
Yeah, why do you have the negative 3?
Why do I have...
Negative 2. And then
Start out as a negative 2. Mm-hmm.
Go over to the problem that you did.
This one?
Go on the other side though. You said 3y minus 2
Oh,
minus 3y.
2. Thank you. Yep, a 2. A 2.
So it's negative 2.
2. Yep.
Okay.
Yeah, thank you. Yep, thanks for fixing that. I just kind of wrote down my wrong thing there. Yep, it should be a 2. Now it makes sense, right? Okay. All right, and so that's what happens with those. So again, if you've got 2 pieces in there, you've got to end up doing your 2 doubles on there. One more of those?
Yeah,
Sure.
I don't get that second part.
Oh, you don't get the subtracting part?
Yeah.
This part?
I don't understand
Okay.
that part.
When we did these guys up here, when we had this piece right there, when we did the other ones, remember we took this piece and added it with a +4, and we took this piece and did it with a -4, because outside of these absolutes, what could possibly come out was a negative. So the same thing happens here, but it's just that this isn't one term or one piece. It's got 2 pieces to it. But again, I'm going to take my first that I have, which I did up here. My first was that y minus 4, left it as a positive, wrote it again, but made the second piece negative. So I did the same thing here. Wrote this piece as it is, wrote this piece as it is.
Move it down just a little bit.
Yep. So I wrote this piece as it was, and I wrote this piece
Alright,
as
yeah,
it was.
I see that. I
But
see that.
then when I did the minus part, I had to minus this piece. So I had to change the signs on that piece in order to work with it. Just like I did up here. I changed the 4 to a negative, so I changed
Oh,
this to the opposite
Alright,
sign there.
I get it.
Okay? Yep.
Yeah.
Good. As long as we're making headway with it. So here's another one that's like that. Can find one in here. Well, I'll do with fractions in it. 2/3 x minus 1 absolute equals the absolute of 1/6 x plus 5 absolute. So we leave this one as it is. We leave this one as it is for my first problem. Okay? We okay with that part?
Yeah.
Little extra choice words coming out over there. Then we do the opposite of this piece. So it's going to be 2/3 x minus 1 is equal to opposite sign on that part. Okay?
Right.
Because inside your absolute, oh, no, you're not asking why on this one? Okay. Okay, so now if I go to solve this, I've got fractions, so I want to probably take everybody and clear out those fractions, right? Multiply this side by 6, because that's my common denominator. 3 goes in 6 twice. 2 times 2 is 4x. 6 times the negative 1 is negative 6. 6 goes into 6 once. 1 times 1 is 1x. And 5 times 6 is 30. Okay? And then finish it.
Would you do it on the other one too, wouldn't you?
Yep, we're going to do the same thing when we get to there. We're going to go through and do this one first.
Alright.
So it gets me 3x minus 6 equals 30. Add 6. 30 plus 6 is 36. Finally divide by 3 and find x is equal to 12. So it could be 12. And then I want to do the same thing over here, but I probably want to get rid of that negative in there first. So 2/3 x minus 1 equals a negative 1/6 x minus 5. Multiply everybody in there by 6. 3 is in 6 twice. 2 times 2 is 4x. 6 times the negative 1 is negative 6. 6 goes in there once, gives me a negative x. And 6 times the negative 5 is a negative 30. The signs on this side changed is all I did. Move it over. Add 6. Negative 30 and a positive 6 is a negative 24. Divide by 5, and I find x could be a negative 24/5. So that would be my other answer that x could possibly be.
Okay.
So then, if I entered it in Hawks, I would enter a negative 24/5, comma 12. Okay? Yes or no? What do you guys think?
You solve the one, and then you solve the second part as negative. Got it.
Two problems. You've got the positive method and you've got the subtracted side. Okay? Yeah. So you always got positive side, then you got to do the opposite with that other side. Yep. All right. What do you think?
Good.
One more? Should we do one more? One more. Okay. Do one more. Then we will finish that part up. Absolute of 1/3 x plus 2 absolute equals 2/5 x minus 4. Two routes. First route, drop my absolutes and write it just as it is. Second question route, leave the first alone. Change the sign on the second one. Because again, I got to do the opposite, because outside of this absolute could be positive or it could be negative. That comes out of there. So,
Way, I'm confused on why it could be negative there.
this piece,
Yeah.
because when we do these, remember the answer that can come out of this side could be positive or it could be negative. And when we had just a number over here, we made one positive and we made the other one negative when we solved it and did two routes. Same thing here. This side could be a negative answer when I solved it, so I have to change the sign on it.
Okay.
Right there. Okay. So, what do I got to multiply by? 15. Yep. 3 gives us 15, 5. 5 times 1 is 5x. 15 times 2 is 30. 5 gives us 15, 3. 3 times 2x is 6x. And 4 times 15 is going to give me, what, 60? What was it? 60. Yep. Now, if you wanted to, right at this point, you could go over, because I've gotten rid of my denominators, I could just go through and write this as a negative 6x minus 60, but do the opposite sign of it right at that point, and get a negative 6x plus 60. And then solve it. So, which x do I move? Well, I guess I move my 5x because it's smaller. Equals x minus 60, so add 60. And I find 90 is what x could be. And then if I do the other one, add 6x. Gives me 11x plus 30 equals 60 minus 30. 11x is equal to 30. Divide by 11. I find x is equal to 30/11. So there's my two answers. I know today was kind of a long, drawn-out stuff, but that's what we have with that.